Howdy, AP PreCal. It is Miss Kosh. This is what I'm going to have my kids do after our previous test and before we really dive into sections 2.1 and 2.2. So this is kind of my intro to sequences. I looked at my IB book and it describes a numbered sequence as an ordered list of numbers defined by a rule. The pre-cal curriculum describes a sequence as a function from the whole numbers to the real numbers. Okay, and I had always just said a sequence is a list of terms. So what's happening here is that I can find the first value of my sequence, the second value of my sequence, the third value of my sequence, and those whole number, the term numbers. So we often will write it like a sub 1 equals, I don't know, my birthday is 6/17. Okay, so a sub 1 equals 6, and then we might say that the second term, a sub 2, is equal to 17. We will find that it's a function that takes the whole numbers of the sequence, which term in the sequence. So this little subscript is how we denote that. Those have to be whole numbers, and it maps it onto the real numbers. So it could be anything. It could have mapped this onto 6 pi if it wanted to, and then this would be 17 pi, or who knows, whatever. Let's not ever think that. But that's the whole idea, that our input values are whole numbers, and our output values is anything we want it to be. Okay, and actually, I don't think it would even have to be a real number, but whatever, just a number. Okay, so we have two ways to describe our formula, and one of them is a recursive formula. So with a recursive formula, I always require you to do two things. That was a number one that I circled. Tell us where to begin, and then number two is and what to do. So here, I tell you where to begin. The first term was equal to 4, and then I tell you what to do. So here's what we're talking about. It says a sub n equals 2, a sub n minus 1, minus 1. Oh my goodness, that's a little confusing. So let's see. If I were looking for the second term, a sub 2, what I would do is I would say it's 2 times a sub 2 minus 1 minus 1. Be careful with notation. So I'm not grading your handwriting, but I'm grading your handwriting. If you don't put this as the subscript, then it's something different. So this n minus 1 was in the subscript. The minus 1 here was not. And so this is equal to 2 times a sub 1. 2 minus 1 is 1, minus 1. Well, it was a sub 1. Well, we just said a sub 1 right here was 4. So this is 2 times 4 minus 1. 8 minus 1 is 7. So the second term of that sequence is 7. Okay, to find the third term, I'm going to take 2 times the term that came right before it. What came right before the third term? The second term. And subtract 1. So 2 times 7 is 14, minus 1 is 13. To find the fourth term, it's 2 times the third term minus 1. So 26 minus 1 is 25. Let's do one more. 25 times 2 is 50 minus 1 is 49. And we developed these recursively, okay? With my calculator, let's see if this works. They're not always this complicated, but what I can do is I can tell it where to begin. I can hit enter, and then I can say 2 times that answer, minus 1. And then if I just hit enter, notice it's going to give me all these terms, and it keeps going. So it generates these terms recursively for me. Oh my. And we always in class have to do this until we can see who gets to the biggest number. Never mind, I'm done. Okay, delete. Nope, I wanted the whole thing. Delete all. There we go. Okay. The other type of formula is what we call an explicit formula. Now this is great if you're wanting to develop things as you keep going. Oh, and also this is a great way to do, I'm not sure if you're familiar with Fibonacci's sequence, but Fibonacci's sequence is fun. It tell me that the first term is 1, and the second term is 1, and then the nth term is going to be the second term plus the n minus 1. So basically what happens is we take the first term and the second term, we add them together to get the next term. Add these two together to get this. Add these two together to get that. Add these two together to get that. 13, these two add to, my brain just stopped, 21. Okay, and I can keep going, and I had students a few years ago, Byron and Ashta, that wrote 100 terms of Fibonacci sequence, and they put it around my wall, and then COVID happened, and I changed classrooms, and it's gone. But anyway, it was very fun and cool. This is Fibonacci. And in order to, I think that's spelled roughly correctly, in order to write this formula with an explicit formula, it's really nasty and gross. So you can Google it and see. All I remember is it has root 5s all over the place. But the recursive formula is really helpful here, but it doesn't help you find the 100th term per se. The explicit formula helps you find any term that you want of the sequence. It's giving you this lovely, so like if I want the first term, a sub 1, I just plug in 1 for n. 1 squared is 1 times 2 plus 1, so the first term here was 3. To find the second term, I have 2 times 2 squared. This is 4 times 2 is 8, plus 1 is 9. Okay, I can keep going. The third term, 2 times 3 squared plus 1, that's 9, 18, so 19. If you catch me doing math wrong, let me know, but be kind. Okay, so 2 times 4 squared, 16, 32 plus 1 is 33. I'm done. But the point is that if I want to find the 10th term, a sub 10, it's 2 times 10 squared plus 1. That's 100 times 2, so this would be 201. Which is a lot easier to find a random term here rather than having to do it recursively, where in order to know the 10th term recursively, I have to know the 9th term. In order to know the 9th term, I have to know the 8th term. The explicit formula lets me pick any term that I want. Okay, so here are some terms. Let's see if we can figure out the pattern. I see 4, 7, 10, 13. Pause here if you don't see the pattern, figure it out, and then turn it back on. Okay, and what we're doing is we're adding 3. And then it said find the nth term. So one way to do this is, well, play around with it, but basically it's this. So I will talk about how to get these formulas more next class. Notice on this one, 1, 4, 9, 16, 25, hopefully you see that this is a perfect square. Those are all perfect squares. And so this a sub n would just be equal to n squared. Because the first term was 1 squared, the second term was 2 squared. On this one, I see 2, 6, 18, 54. It appears to me that I'm multiplying by 3. And one thing, I can do this, I can generate this recursively if I don't feel like. I can say 2 and then put times 3. So this is 162. I didn't give myself enough space. 486. Nope, that's not. Yeah, okay, I said it right. I didn't write it right. 486, multiply that by, and I see 1458. Okay. The next one, it looks like I have a third of my value each time. I could do it recursively, but that's right. Okay, on this one now, they've made these shapes with toothpicks. So I see 1, 2, 3 toothpicks here, and now this has 2 on this side and 2 on this side and 2 on this side, so we have 6 toothpicks. Now I have 1, 2, 3 on each side, so that's 9 toothpicks. So what am I doing each time? I'm adding 3 more. Excuse me. So the next one would have 12, and then the next one would have 15. Okay, and this is cool. This is called I don't know if it's Von Cook or Von Cook. I don't know. I have seen people whose name's spelled this way, and they say Cook, but I don't know. I see 3 sides, but then you'll notice that one of these sides, say this side right here, became 1, 2, 3, 4 sides this time. So I had 4. And then I have 4 on this side and 4 on that side, so this one has 12 sides. And that pattern is a little tricky to keep counting, but this becomes 48. And this is something we can do recursively, 3, and then each previous side now has become 4 more. Okay, so we're at what? This is 192, and this is 768. And this would be 3072. So it's really kind of fun. Go Google that because I think you'd enjoy it. Okay, write the first 5 terms of these sequences. Plug in 1, I get 5 minus 2 is 3. Plug in 2, I get 10 minus 2 is 8. Plug in 3, I get 15 minus 2 is 13. You might notice that this is got a common, it does have a common difference. We're going to talk about that next class. This has the average rate of change, the slope of this is 5, so we're just adding 5 each time. Okay, or I could plug in 5, that's 25 minus 2 is 23. Okay, the next one, I have 1 squared is 1 plus 3 is 4, 2 squared is 4 plus 3 is 7, 3 squared 9 plus 3 is 12, 4, 16 plus 3 is 19. If I make a mistake, tell me nicely. 28, so 25 plus 3. On this one, we're plugging in 1, so we have 80 times 1/2, which would be 40. And then we have to multiply, then we have 80 times 1/4 is one way to do this, or to recognize it's 40 times another 1/2. If either way I said it, 80 times 1/4, that's 20. Or half of 40 is 20, and then it's 10, and then it's 5, and then it's 5/2, or 2.5. Okay, here were some recursive formulas. So I have 4. I take to find the next term, I add 7. So it tells me what to do. No, it tells me where to start. Start at 4. It tells me what to do. It says add 7. Okay, so add 7, add 7, add 7, add 7. I can do this one recursively also. Delete, delete. I can say 4, enter, and then plus 7, enter, enter, enter. Did we rewrite? And once again, I can keep going. But okay, here, this is the first term was 2. Multiply it by -3, I get -6. Multiply it by -3, I get 18. Multiply it by -3, I get -54. Multiply it, I think, by -3, what is that? 150 plus then 12 more. So it's positive 162. Did I make sense? I hope so. This is a fifth of whatever we had. So the first term is 625. A fifth of that is 125. A fifth of that is 25. A fifth of that is 5. A fifth of that is 1. Just to make sure that Ms. Kosh still knows what she's doing at the end of the day. 625 times, I can make this 1/5 or 0.4. Not 0.4, 0.2. Oh, good. She knows what she's talking about. That's awesome. Okay, that was the intro, and I picked some problems for my kids to work from my IB textbook because there we go. That's just what I did for you. So go practice some of this stuff and like, subscribe, comment, and all the things, and I'll see you later.